For 17 and 18, we need to find a variety of information from the indicated graph. So the domain is the set of all x values. So when I do the set of all x values, I have to look at these arrows, because these arrows tell me that the line keeps going forever, so I want to know where does it go. And I break it up into its horizontal and vertical components. The horizontal components is the ones I care about right now. So let me actually do those in a different color. So the horizontal components go left forever. So let me do that in green, and right forever. So the domain goes left forever, it comes down, does a little V shape, and then it goes right forever. So I don't miss any x values. I go from negative infinity all the way to positive infinity. Now, for the range, it goes up forever and up forever, so I do know that I'm going to get to infinity in the positive direction, but notice in the bottom, I have a lowest point. So because my shape is a V shape down here, the lowest value I can possibly have in my y direction is negative 3. So the lowest I can get is negative 3, comma, all the way up to infinity. So if you turn your pencil sideways and try to drag it up, you'll see that it hits negative 3, that's the lowest it can be, and then it keeps going up forever. Because it can include negative 3, we put a bracket. Some students ask at this point, hey, well, when would you use a parentheses? You always use a parentheses with infinity. If this point down here was an open circle, then you'd have to use a parentheses, but that doesn't happen very much. So usually points are defined as closed until you have an open circle. So even though this isn't a big fat point, it is automatically closed until someone comes along and puts an open circle there instead, which means it's open. The x-intercepts, written as ordered pairs, you're just looking where does the graph hit your x-axis. It looks like it hits the x-axis at negative 2, so we write that negative 2 comma 0, and it also hits at positive 4. Now, if you can get your x-intercepts right, you should be able to get your zeros right, because a 0 is just the list of x-coordinates of the x-intercept. So negative 2 and 4 would be the two zeros, but the x-intercept would be written negative 2 comma 0 because that's actually a location on the graph, and 4 comma 0 because that's a location on the graph. The zeros are just at what value is the graph at 0. So basically the same kind of answer, but they're written differently. So the next one we're looking for is the y-intercept. So if you look up and down the y-axis, then you see the point at which it crosses, and that looks like at negative 2. The location of that graph is 0 comma negative 2. Next I'm trying to find f of negative 3. So if I'm trying to find f of negative 3, I'm going to go to negative 3 on the x, and I look up and down until I can see, oh, there it is. There's the one value right there on the graph. So when the graph is negative 3, it's touching the point negative 3, comma 1. So if x is negative 3, then the y value is 1. That's the answer I'm looking for. Basically, this is asking, if x is negative 3, what's the y? So when I'm trying to find f of positive 3, I go over to the positive 3 and I look up and down. Oh, there it is right there. The point is 3 comma negative 1. So if x is 3, then y is negative 1. And that's how you find those values. Let's do this all over again. So in domain, I'm looking left and right. So left and right, the arrows are going to go left and up forever, and right and up forever. Notice that the arrows, they look, some students will say, but miss, that's going straight up. Well, no, it's not. Because it's a parabola, it continues to go out just ever so slightly, much slower than it goes up, but it's still continuously going out forever. So please make sure that you see that as going left and right forever, meaning the domain is negative infinity to positive infinity. The range, how low can we go? The lowest we can go is negative 4, comma up forever, that's positive infinity. The x-intercepts, let's see, crosses the x-axis twice, so that's negative 3 comma 0 and 1 comma 0. If you can get that right, automatically come down and do the zeros, which are negative 3, and 1. Sometimes you might only have one x-intercept, and therefore you'll only have 1, 0. If you have two x-intercepts, then you must also have two zeros. My y-intercept, let's see, that looks like 0, comma, -3. And when I'm trying to find my values, if we're trying to find f of -1, so if x is equal to -1, looks like my y value, -1, comma, -4, is -4. Okay, well, what if x is -3? So f of -3, that's 1, 2. -3 is right here, so it looks like it's right there on the x-axis, which is -3, comma, 0. So if x is -3, then y is 0. On the last page here, we're looking for solving absolute value equations and absolute value inequalities. And now you might be looking at this like, oh my goodness, what, she really loves absolute value. There's 5 of them on this test. Well, the reason there's 5 of them on the test is because every single one of these is different, and I had to test you on each one of them. So don't think, oh, she's just repeating the process over and over again. If you're repeating the same process, then you're probably not doing it right, because each one needs to be interpreted differently. This first one is an equals. Okay, notice the instructions say solve the following equations or inequalities. So this one happens to be the only equation. The rest of them are all inequalities. When we're solving equations, first thing you need to do is make sure that the 5 is positive, which it is, so there's not negative there. If it was negative, then we'd have no solution and we'd move on. Okay, that's after making sure these absolute values are all by itself. So because 5 is positive, I'm going to keep going. So that gets me 4x minus 3 is equal to, we're going to break it up into two equations. What I'm going to do is this inside, 4x minus 3, can either be 5 or it can be -5. I don't really care which order you plug it in, but if you plug in -5 into the absolute value, you're going to get 5. Similarly, if you plug in 5, you'll also get out 5. So this inside bit is allowed to either be -5 or, so make sure you put the little or here, it could be equal to 5. So now what we're going to do is solve each of these equations. On the left equation, I'm getting 4x is equal to -5 plus 3. That's -2. Divide both sides by 4. I'm getting x is equal to -1/2. Okay, so that's one answer that would solve the equation. Or, let's solve the other equation. I'm getting x is equal to 2. So the two answers are -1/2 and 2. You don't have to check this. You can if you want to. There's only two answers that would possibly work for this equation because we need to equal 5. On the next several problems, you're going to have an interval of answers because there's going to be lots of answers that solve an inequality. There's usually only a finite number of solutions to equations, but in this case, with inequalities, there's lots. So we need to identify, step 1, is the bars all by themselves? Sure they are. Okay. Step 2, is the 10 positive? Yeah, it is. Okay. So because those two things are qualified, we can now decide, is this a less than which problem or a greater? Well, because this inequality kind of looks like an L, this is going to be a less than which problem, which means I'm going to sandwich the x minus 7 between 10 and -10. Now I can solve by adding 7 to all three sides, and that's going to get me x, let's see, -10 plus 7, that's a plus, kind of doesn't look like a plus. -7 plus 10 is -3. So that is my answer in inequality notation, but no one asks for the inequality notation, they ask for it in interval notation. Now I find it easiest to graph this on just a simple number line of open circle, and x's in between, so therefore it's in between, and then I can use this picture to get my interval notation, which is -3 is the lowest I can go, comma, how high can it go? 17. So this is the interval of all of the answers between -3 and 17, but not including the endpoints. Okay, on our next problem, notice the bars are all by themselves. There's nothing being added or multiplied outside the bars. Okay. Next, is 16 positive? Yes, it is. Good. Okay, so because 16 is positive and the bars are already by themselves, I can proceed. I have to decide, is this a less than which problem or a greater? The inequality is greater than or equal to, so therefore it's a greater. Because it's a greater, I know I have an or in my problem. I'm going to split this up into two equations. I know I'm going to take the expression out of the bars. One of the equations is exactly the same. I usually like to put that on the right-hand side. The other inequality is going to be switched. Greater than turns into less than, and positive 16 turns into negative 16. So that means two signs switches. The inequality sign switches, and then the sign of the 16 also switches. So now I have two inequalities without bars. Because they're without bars, that means I can solve them. So I'm going to subtract 4 from both sides. Notice you could not have solved this when it had bars on it still. You can't pull it out of the bars until you use the rule to pull it out of the bars, and we did. So we have x is less than or equal to -10. That is in inequality notation. So I need to put it in interval notation, so I'm going to go ahead and graph it because that helps me to get it in interval notation. Okay, this looks like x is greater than or equal to 6. Okay, so positive 6 is to the right of -10, and x is greater than, that also goes to the right. So now that I have this is in inequality notation, so that's not sufficient. Then I graph it, but now I can get interval notation. Make sure you put it in the right form. So how low can I go? -infinity, comma, how high can I go? For the branch on the left, the highest I can go is -10. Union mean as well, or 6, that's inclusive, so I use the bracket, to infinity. That is my answer in interval notation. If you don't give it to me in interval notation, you're not going to get your full credit. Okay, on our next problem, number 23, we have absolute value bars. Are they isolated? Yes, there's nothing being added or multiplied outside the bars. We have less than or equal to -4. Is -4 positive? Whoa, it is not positive. Okay, so that means I cannot make this a less than which or a greater. This means this is a special case, and because it's a special case, I know the answer is either all real solutions or no real solutions. Okay, so let's see. I know that if ever I take the absolute value, I'm going to get some positive answer or 0. Those are the only things I could get, positive things or 0, because that's what absolute value does. So my question is this statement always going to be true or never going to be true? Are positive things always less than -4 or never less than -4? Less than negative. No, positive things are never going to be less than -4. Therefore, my solution is no solution. That's the answer, okay? You cannot actually do this problem. If you do a less than which on this problem, you might get an answer and it's going to be totally wrong because it doesn't even make sense. You can't ever have the absolute value being less than a negative. It just doesn't make any sense. On our last problem, we have 8x plus 2 is greater than -1. Okay, so first off, are the bars by themselves? Yeah, 8x plus 2 is all by itself in the bars. There's nothing being added outside the bars, nothing being multiplied outside the bars, so they're done. So next the question is the number to the right of the inequality positive? Well, -1 is not positive. So this is a special case again. So we know that the inside the bars, whenever you evaluate it, is going to be something positive or a 0. So my question is, are positive things, or 0, always greater than -1 or never greater than negative 1. Well, positive numbers are always bigger than negative 1, so this is always true. So because it's always true, the solution, the only solution that's going to be accepted here, is all real numbers. The way we write all real numbers in interval notation is negative infinity, comma, positive infinity, and we always use parentheses on infinities. And that concludes this practice exam.